Hello guys, welcome back. Today we'll be treating the course Engineering Survey and our topic is numericals on obstacles to chaining. Please stay tuned and listen. Okay, so today we'll be treating numericals on obstacles to chaining and obstacles to chaining like ponds, rivers. So first question says a chain line ABC crosses a river at 90 degrees as shown in the figure. B and C are 2 points located near and far the river bank. So this is B and C, and this is the river, and this is line ABC. So we have that this is 90 degrees, and we also have that the total of this is a 90 degrees. So, and how do we find BC? So you would look at the diagram and know how you would resolve it using trigonometric ratios. We know that we are looking for BC and we have this side as 100 meters. If we can find this angle, it will be easy for us to use SOHCAHTOA. Since if we have this place as 90, we also have this place as 90 degrees, right? All right. But we don't have this angle here. Is it possible to get this angle here and subtract it from 90 since we have the total of here 90? So let's look at it. We have this side, we have this side, we have two sides, and we have here as 90. And we are looking for this angle. Let's call this angle alpha. So we have making this we have the adjacent and we also have the opposite. We all know that the longest side is the hypotenuse. So adjacent and opposite, what's the relationship? Tan. So tan alpha is equal to adjacent over opposite, right? Which is equal to dB over AB, which is equal to 100 over 57.73. So tan alpha is equal to 1.7322. That's 100 over 57.73. So alpha will be equal to the tan inverse of 1.7322, which is equal to 60 degrees. So we have this at 60 degrees, and we know that, let's call this theta. We have theta plus alpha, which is equal to 90 degrees. We agree, right? So theta will be equal to 90 minus alpha, which is equal to 90 minus 60. So theta automatically becomes 30 degrees here. So if we now have the degree here as 30 degrees, and we are looking for this side. So we have the angle here, making this again the adjacent, making this again the opposite. So we now have tan theta will be equal to adjacent all over opposite, which is equal to 100 over BC. And we have tan as 30. So tan 30 will be equal to 100 over BC, making BC subject to formula. BC now becomes 100 over tan 30 degrees. So BC equal to 173.21 meters. That's all for this example. So for this second question, I've already solved it. So let's get on with the explanation. So it says that a big pond obstructs a chain line AB. So this is the chain line AB shown in the diagram. A line AL was measured on the left line of AB, on the left side, and then AM is on the right side of AB for circumventing the obstacle, which is the pond. The length of the line AL is 901 meters and AM is 1100 meters. BL as 502 and BM as 548 as given in the question. So they said we should find the width of the river AB. And looking at it, we need here, from here to here. We can look at, okay, just this triangle now. We have this side, this side, this side. And when you have three sides and an angle, you know that, let's change this to three sides and an angle, you know that you are going to use cosine rule. So what does cosine rule actually state? Cosine rule states that if you have a triangle of three sides, A, B, C, and an angle, one angle given, to get, let's say this is the unknown that you're looking for, right? So a square will be equal to b square plus c square minus 2bc minus 2 times this cos alpha. That's cos of the angle that you're looking for. So if we are going to use that here, we don't have this angle, but we can look at the whole triangle and see that we have 1, 2, 3. We have the 3 sides. So what can we do? We can make this angle the subject of formula, right? So summing up these two, we're going to just take this triangle here and just reproduce it here. So 502 plus 548, we get 1050. So we're going to now take this idea of cosine rule and apply it to this triangle. So it will be 901 square is equal to 1050 square plus 1100 square minus 2 times this and this times the cos of the angle we are looking for according to cosine rule. So we are going to make cos alpha subject of formula. So automatically this moves here. That's 901 square minus 1050 square. This also moves here, minus 1100 square, right? We know minus 2 times 1050 times 1100 is the coefficient of this cos x. So we are going to, it's going to come out and then it's going to be divided by this whole thing, right? So when you input it and you punch it inside your calculator, you get 0.649 cos alpha. So to get alpha, we know that we'll do the cos inverse of 0.649, right? So alpha will be equal to 4953. Successfully, we've been able to get 4953. But don't forget, we are still looking for the width of our river, AB. So we have this side, this side, this side, and an angle. We're still going to apply cosine rule, right? So we're just going to bring out this half and then reproduce it here. This is the side that we are looking for, the width of the river. And then this is 548 from here. And then this is 1100 meters from here. So we're still going to do AB square, remember from our cosine rule, is equal to 548 square plus 1100 square minus 2 times 548 times 1100 cos 49.53, the angle here, right? So once we punch that in our calculator, we get 727,809.547. So after getting that, we will definitely want to take the square root because this also has a square here. So AB automatically be equal to 853.12 meters. Alright, so for the next example, they said we should find the width of the river BC, and we know this is the river, right? So don't let the diagram confuse you. Once you can just manipulate your way into getting your answer, you are good to go. There are different methods, different varieties of methods to getting your answer. So the method I might use might be different from the method another person would use. But you can use angles to get this for this question. But the simplest method we can find is the use of similar triangles. So we are going to look at this triangle here, and we're going to also look at this other triangle here, right? And we see that we can actually apply similar triangles. So we are going to say BC, this is BC, taking this first triangle into consideration. BC over 60, that's the height over the base, is equal to the height of this, that's 80 over the base of this, which is 40. So we are going to make BC subject of formula. So, this times this times this becomes BC. 40 BC is equal to 80 times 60. So making BC subject of formula, 60 times 80 over 40. BC is equal to this over this, and then we have 120 meters. That is all for this question. Okay, so these are some trial questions I want us to try out. Having solved a few examples, please try and solve them. They're actually pretty